Hello friends, my name is Ramasu. Today we shall discuss about a topic that what is machine learning. Friend, today's topic is very interesting, especially if you have interest in technology like machine learning. So this is a very interesting and important topic for you. So let's start, friend. First of all, I would request to please subscribe to my YouTube channel and click on the bell option as well, so that many videos can reach to you. And also you can follow me on the Facebook page as well. So what is machine learning? Machine learning is a type of artificial intelligence AI that allows software applications to become more accurate at predicting outcomes without being explicitly programmed to do so. Machine learning algorithms use historical data as input to predict new output values. Recommendation engines are a common use case for machine learning. Other popular uses include fraud detection, spam filtering, malware threat detection, business process automation, and predictive maintenance. Now, why is machine learning important? Machine learning is important because it gives enterprises a view of trend in customer behavior and business operational patterns, as well as supports the development of new products. Many of today's leading companies such as Facebook, Google, Uber make machine learning a central part of their operations. Machine learning has become a significant competitive differentiator for many companies. What are the different types of machine learning? Classical machine learning is often categorized by how an algorithm learns to become more accurate in its predictions. There are four basic approaches: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So, what is supervised learning? In this type of machine learning, data scientists supply algorithms with labeled training data and define the variables they want the algorithms to assess for correlations. Both the input and the output of the algorithm is specified. Unsupervised learning. This type of machine learning involves algorithms that train on unlabeled data. The algorithm scans through data sets looking for any meaningful connection. The data that algorithms train on, as well as the predictions or recommendations they output, are predetermined. Semi-supervised learning. This approach to machine learning involves a mix of the two preceding types. Data scientists may feed an algorithm mostly labeled training data, but the model is free to explore the data on its own and develop its own understanding of the data set. Reinforcement learning. Data scientists typically use reinforcement learning to teach a machine to complete a multi-step process for which there are clearly defined rules. Data scientists program an algorithm to complete a task and give it positive or negative cues as it works out how to complete a task. But for the most, the algorithm decides on its own what steps to take along the way. How does supervised machine learning work actually? Supervised machine learning requires the data scientist to train the algorithm with both labeled inputs and desired outputs. Supervised learning algorithms are good for the following reason: binary classification and dividing data into two categories, multi-class classification choosing between more than two types of answers, regression modeling predicting continuous values, combining the predictions of multiple machine learning models to produce an accurate prediction. Now, how does the unsupervised machine learning work actually? Unsupervised machine learning algorithms do not require data to be labeled. They sift through unlabeled data to look for patterns that can be used to group data points into subsets. Most types of deep learning, including neural networks, are unsupervised algorithms. These are the reason. Then semi-supervised learning works by data scientists feeding a small amount of labeled training data to an algorithm. From this, the algorithm learns the dimensions of the data set, which it can then apply to new unlabeled data. The performance of the algorithm typically improves when they train on labeled data sets, but labeling data can be time consuming and expensive. Semi-supervised learning strikes a middle ground between the performance of supervised learning and the efficiency of unsupervised learning. Now, how does the reinforcement learning work? Reinforcement learning works by programming an algorithm with a distinct goal and a prescribed set of rules for accomplishing that goal. Data scientists also program the algorithm to seek positive rewards which it receives when it performs an action that is beneficial toward the ultimate goal, and avoid punishments which it receives when it performs an action that gets it further away from its ultimate goal actually. Then, who is using machine learning and what is used for? Today, machine learning is used in a wide range of applications. Perhaps one of the most well-known examples of machine learning in action is the recommendation engine that powers Facebook news feed. Facebook uses machine learning to personalize how each member's feed is delivered. If a member frequently stops to read a particular group's post, the recommendation engine will start to show more of that group's activity earlier in the feed. Behind the scenes, the engine is attempting to reinforce known patterns in the member's online behavior. Should the member change patterns and fail to read posts from that group in the coming weeks, the news feed will adjust accordingly. In addition to recommendation engines, other uses for machine learning include customer relationship management. CRM software can use machine learning models to analyze email and prompt sales team members to respond to the most important message first. More advanced systems can even recommend potentially effective responses. Business intelligence. BI and analytics vendors use machine learning in their software to identify potentially important data points, patterns of data points, and anomalies. Human resource information system. HRIS systems can use machine learning models to filter through applications and identify the best candidates for an open position. Self-driving cars. Machine learning algorithms can even make it possible for a semi-autonomous car to recognize a particularly visible object and alert the driver. Virtual assistants. Smart assistants typically combine supervised and unsupervised machine learning models to interpret natural speech and supply context. What are the advantages and disadvantages of machine learning? Machine learning has seen use cases ranging from predicting customer behavior to forming the operating system for self-driving cars. When it comes to advantages, machine learning can help enterprises understand their customers at a deeper level by collecting customer data and correlating it with behaviors over time. Machine learning algorithms can learn associations and help teams tailor product development and marketing initiatives to customer demand. Some companies use machine learning as a primary driver in their business models. Uber, for example, uses algorithms to match drivers with riders. Google uses machine learning to surface the ride advertisements in searches. But machine learning comes with disadvantages. First and foremost, it can be expensive. Machine learning projects are typically driven by data scientists who command high salaries. These projects also require software infrastructure that can be expensive. There is also the problem of machine learning bias. Algorithms trained on data sets that exclude certain populations or contain errors can lead to inaccurate models of the world that at best fail and at worst are discriminatory. When an enterprise bases core business processes on biased model, it can run into regulatory and reputational harm. So friend, thank you, thanks a lot for watching the video. I hope you like this video. If you like it, please share it with your friends and colleagues, and thanks a lot for watching the video. Thank you friends.